Google Research has come up with yet another groundbreaking paper. This paper presents an exploratory study of the 3D awareness of visual models, which means that how well do the representations capture the 3D-ness of the scenes and objects. In this paper, they posit that 3D awareness implies representation that first encode the geometry of the visible surface, and secondly, they are consistent across views. They have used trainable probes and zero shot inference methods to evaluate the frozen features of this model, which is quite unique in my humble opinion. If you look at this diagram from their paper, and I will drop the link to their paper in video's description, this is where they probed the 3D awareness of the learned representation by evaluating their ability to encode the 3D structure of the visible surface and their consistency across views. The results show that visual foundation models learn representations that encode the depth and orientation of the visible surface, with vision language models being the notable exception. They have also found out that while models can estimate accurate semantic correspondence as well as correspondence across images of a similar viewpoint, they struggle with large viewpoint changes. This also indicates a lack of multi-view consistency and suggests that models are learning representation that are view consistent and not 3D consistent. One possibility is that the models are learning view dependent representations. This could be similar to the theories of shape perception proposed by various other researchers, where shape perception is achieved by a series of view specific representations connected with an aspect graph. Another possibility could be that it is the current model. They are very good image models, and that good discriminative features are sufficient for strong 2.5D understanding. So these researchers are really hoping that their findings can simulate more interest in understanding the 3D awareness of visual models, and that many more research would be on the way on the basis of this work, in my opinion. For instance, if you look at this image from the paper, in this one, they are showing depth estimation results. So while pre-trained representation show large variation in their ability to represent depth, their performance is consistent on objects and scene. Clip and MAE features do not encode depth and appear to instead capture rough priors such as floor pixels are close, as you can see in this figure. Most models appear to capture the rough structures of the scene and vary in the degree to which they capture details. DINO version 2 performs best and accurately captures fine details, for example, cow's ear, desk chair, and also the coffee table, as you can see in this image. Having said that, even this paper is not really ideal and it struggles with several limitations. For example, they used pre-trained checkpoints that were often trained on different datasets and with different compute scales. And to the credit of researchers, they have also acknowledged that while this allowed them to explore a broader set of models and tasks, it would be useful to make more targeted and fair comparisons to better understand the impact of training signals. Also, they focused on minimal probing approaches to analyze the pre-trained representations. It would be useful to explore other probing techniques, as it remains unclear what is the best way to understand the distributed representation learned by visual models. And finally, their analysis only explored two basic aspects of 3D understanding. But 3D awareness and understanding are closely related to more complex and higher order tasks such as perceiving 3D shapes, reasoning about spatial relationship, as well as making predictions about deformation and dynamics. But this is only the first step towards understanding the 3D awareness of visual models. And this is becoming more and more relevant as the recent image and video generation models have achieved impressive feats of photorealism and temporal consistency. This really makes it a very exciting time to delve into understanding what those models have learned and whether or not they learned about 3D structure of the world in the process of learning to generate it. So it is really a huge hope that their finding will stimulate more interest in understanding the 3D awareness of visual models, and that future research could provide more insight into how model represent the world and impact of the learning objectives of such representation. That's it, guys. I hope that you enjoyed it. Let me know your thoughts on it. If you like the content, please consider subscribing to the channel. And if you are already subscribed, then please share it among your network as it helps a lot. Thanks for watching.